Our keynote speaker this morning is Steve Franconeri, who is a leading teacher and speaker on data storytelling, dashboard design, and persuasive presentation. He synthesizes practical guidelines from research on cognitive science, data visualization, education, graphic design, and persuasive rhetoric, and distills the most critical guidelines through extensive collaboration and teaching across Kellogg MBAs, executive MBAs, PhDs across scientific fields, and analysts and leaders in over 100 organizations that span nonprofits, education, healthcare, pharmaceuticals, energy, technology, telecommunications, CPG, financial, actuarial, and law. It's a lot of areas, Steve. So I hope that you'll all really enjoy this opening keynote, which I think will really center us on some of the cross-cutting principles and practices that apply regardless of what kind of visualization design work you're doing. Whether you're building an interactive, fun graphic like VizHeads, or you're building more practical analytical applications like the example from McLaren yesterday. And so I hope that we'll have a great morning and a great conference day being kicked off by our keynote, Steve. Thanks, Steve.
Thank you, Amanda. I got this. I'm good. Good morning, y'all. TLDR. Usually, when we think about visualizations, we think about the power of the visual system. The visual system's huge, super powerful. And then language, on the other hand, spreadsheets, reading numbers, reading text is slow. I want to give you a little bit of a more subtle story today. I want to tell you about how the visual system can operate fast, but it can also operate slow. And the importance of understanding why and when it operates slowly so that you can tell data stories that load the right kinds of comparisons and semantics into your audience's heads. This is a quick intro to me and what I do. I'm a researcher. That's our lab up on top. Those are all the brilliant people that do all the great work. The stuff on the bottom is just a little sampling. We do research. We publish a lot of what we do in Chi and IEEE Viz, and so we A/B test things and we try to link them to cognitive science. So here's what I want to show you today. First of all, in contrast to slow and serial language, data visualization strive to rely on a powerful processor. And then I'm going to show you that it ain't that powerful all the time. So let me give you some of the standard demos about your visual system, about how powerful it is. That's where your visual system lives. It's in the back half of your head. It actually starts in the back. You got the two eyes in the front, but then there's two cords that go through the middle, and then they hit the back of the head. If you touch in the back of your head, there's actually a bump back there. You can touch it. It's okay. Everybody's all nervous. You're not technically a doctor, so I can tell you, you're going to touch it. You're not going to hurt yourself. That's called your inion. Weird anatomical term. It's like Minions, the movie, but take off the M. Your visual system starts back there, actually wraps around the backs of your brain lobe. There's a bit of cortex back there that's about this big, that has a pixel and edges version of the world. And then from there, on the sides of your head, you process people, places, things, the facial expressions of the people around you. And then there's another stream from there up to the top of your head that processes visual space in a way that lets you grab objects, navigate the world, etc. So all in all, depending on your nerdy operationalized definition, 40–50% of the meat in your head is dedicated to visual processing. So I can show you an image like this, and everybody in the room just yelled, "Squirrel! Corn, tree." Wow, they actually literally yelled it. That was awesome. And guess what? You did that within 130 milliseconds. You parallel process all the colors, textures, orientations, high-level object identities in that picture, their spatial configurations, 130 milliseconds. That number makes no sense. Let me couch it for you. Blink your eyes as fast as you can. Down to up, fastest person in this room was 205 milliseconds. That's the record holder in this room. Your visual system processed the whole image in half that time. That's how much power you're working with. Let me prove to you just how powerful your visual system is. Just keep your eyes on that screen. These images are going to go by at about 2 or 3 per second. And as they're flying by, you are processing the colors, the orientations, the textures, the high-level object identities, their spatial configurations, blah, blah, blah. You're actually, even involuntarily, committing a lot of this information to visual memory. You can't help it. Visual memory is mostly just residual activation in the same circuits that power your visual system. So you're committing a lot of detail from these images to your memory. Not photographic level detail. Photographic memory is actually mostly a myth, but you are committing enough that you're going to ace a memory test in a moment. And you're doing that at the same time as you're paying full attention to what I'm saying. You can also multitask, where you can listen and look at the same time. Can't listen and read at the same time. Can't listen and process numbers visually at the same time, but you can listen and look at the same time. So let me ask you, which image have you seen before? Oh, I don't have a computer to press this. I'm going to use the clicker. Which image have you seen before? Please point left or right and yell left or right. Very nice. Awesome. Cool. Faster. That was the trick question. Very nice. In psychological research, we call that the catch trial. So that's the one. Glad. Good inhibition. Very nice. So I hope you believe me, you have an incredibly powerful visual system. We could do this all day. Literally, come to my lab, 10,000 pictures, all day, sitting there. And then next day you come back, next day, left, right. And you'll get 89% accuracy. So that's the kind of power we're working with. So you get insane power for recognition, and you look at this image and you say, cool, berries, leaves. But that's not where the power of data visualization comes from. That's the more on the sides of the head stream, recognizing objects. You have that top of the head stream that lets you run stats on images really quickly. So y'all can look at this image right now, and you can say, oh, there's about 10 berries in total. There's more reds than blues. The blues are bigger on average than the reds. So you're running analytics on a visual scene. And what we do when we make a data visualization is we're taking some numbers from an Excel sheet and we're mapping them to visual channels to use that same equipment. Ooh, nice dissolve. What? You want to see that again? Okay, nice dissolve. We're using that same equipment to be able to take column A, column B, column C of those numbers and map them, in this case, to vertical space, horizontal space, and the size of the object. So you're just leveraging that same machinery over again to run stats on a fake visual that you made up a bunch of numbers to trick your visual system into analyzing the numbers. And that's the more complex version that you're probably familiar with of that same visualization. So you can get a lot of information quickly from that thing. Here's another example. Shall we just read a spreadsheet? Shall we go and just read a bunch of numbers and use that little verbal system that's right here in the head? Anybody see any particular pattern of numbers in this grid? We have a lot of people that stare at spreadsheets all day. Maybe you do. No, you don't, even though you have a lot of practice in this. If you did, you'd be weird. If you did, you come to my lab and we study your brain because there's something different about you, and we want to put our electric shower cap on your head. We have one. It's awesome. It's gel. You have to shampoo afterwards. It's good times. And then, no, you're not getting anything from this. Let me run conditional formatting on the sucker. Let me put it into some kind of heat map channel, and now the diagonals pop. Easy peasy. You've got the pattern right away. So these are the kinds of demos you typically get, right, to see that data visualizations are powerful. Let me give you one more. I got a bunch of data that's in text now. 2 of these sentences are incompatible with each other. Who will discover that incompatibility first? Let's see who's going to have the highest IQ in the room. And at the same time as you're doing this, I'm going to quickly speak over this text like we all do to each other when we have presentations or meetings at our companies, and there's a bunch of text up on the screen, but you can't because you're multitasking right now, because language is the same circuit that comes in through your eyes and through your ears, and it can't do both right now, and you're getting progressively more annoyed at me, and you just want me to make the point that there is nothing on the left that you need on the screen anymore, and you just need the thing on the right, and you've already processed this thing literally 1,000 times faster, and I can ask you questions about it. I can say, who's producing the most unobtainium? And you say, Asia. Who's gone down the most? And you might say, Antarctica. Who's gone up by about the same amount? You might say, Australia and Europe. So that's much more efficient processing. You can memorize this, right? This will stick in your memory 10 times better than the verbal equivalent, and we can have a conversation over it. So these are the kinds of demos that we typically get of the power of visualizations. But what I want to show you is that, yeah, visualizations can be incredibly powerful, but there's one weird trick that really slows it down. Whenever you want to make a particular comparison, pick out that this thing is higher than that thing, that slope is higher than that one, it's really slow, especially when you then have to link this thing is higher than that one to the semantics, to the labels, to the more verbal thinking problem. You really slow down. So I want to give you a bunch of demos to prove that to you. You know that vision can be slow. Check out this picture. You analyze the whole thing. You know what was going on, 130 milliseconds. Cool. But who read, and I'm sorry if this is a US, UK centric thing, who read Highlights magazine when they were a kid? Cool. I didn't know it was still a thing. Thank you. Where are the differences between these two pictures? You don't have to explicitly identify it. I just want to show you that it's hard, right? So you've all played this game This is basically what I studied in grad school, is why is this baby stuff, but then this is insanely hard? Why is it tough to find Waldo? That's the kind of stuff I did. Grad school was good times. So that's what I did then. And what I do now is, why is this so hard? So here's your company's financials. We are selling a bunch of stuff. On the left side, we have last year, and now we have the same months for the current year. Which products have gone up? Go. Have more products gone up or more products gone down? Go. Yeah, you know what I'm seeing out here in the audience right now? You all look like, you ever see like one of those TikToks of a bunch of cats watching a ping pong game? This is what I'm seeing right now. The entire room is looking like a bunch of kittens watching ping pong. This is going to take a while, right? This is going to take you like 15 seconds to be able to figure this out. This is the kind of place where vision gets really slow. Let's add a legend. Ooh, is that going to help? Let's put down all these products. Let's selling a lot of hens. We're selling, for some reason, more hens than eggs. I don't know. That doesn't make much business sense. I think I need some DI help. No, this is making it worse, right? Now we got two places. Two places where you got this sort of memory load and looking back and forth. We just increased this to a 30-second read. Not cool. Let's do the kinds of things that folks in this room would do, right? You got this, and now let's take the labels. Let's get rid of the legend, directly label stuff. Let's turn the graph over so that we can read the labels a little bit better. And when you read this, what I want you to see is that the way you're actually reading this under the hood, what's going on in the back of your head, why is it the kittens are watching ping pong? The reason is that when you read this, what you're actually doing is, and those of you that use Tableau or similar products can kind of see what I'm doing, you're literally doing what Tableau does in the back of your head. You're literally like clicking on red in your visual system and you're turning up the gain on red, and you're just looking at those two bars at once. And then you're turning up the gain on purple so you can check out how our sales of owls are doing. And you can see how this process is slow, it's serial, it's really one thing at a time. So whenever you're using color in your visualizations to code categorical variables, people have to do this process to be able to pull them out. This is one of the reasons why adding color to a visualization to identify categorical things like this can really slow down your viewers. I want to show you how powerful these filters can be, these filters for colors. I'm going to give you a test. You're going to run an experiment now. We are going to give you a scatter plot, and you're going to tell me in that scatter plot, you're really interested in the purple X's. And you want to tell me, do the purple X's tilt this way, or do they tilt this way? So can everybody just put your hand up like this, and just as fast and as accurate as you can, please say tilt this way or tilt that way. Ready? Go, and go, and go. You're too good at this. This room is a bunch of graph experts. You are perceptual athletes when it comes to reading graphs. This is like, I'm like in the Olympics right now. What am I doing? Let me give you something tougher. Let me add some other junk to the display that you have to filter out. Let me give you some other stuff that you're not concerned with right now. So just focus on the blue axis. And what you got to do in your brain is you got to do that, right? You're going to have to do that. Let me give you one. Ready, go. Ready, go. Ready, go. Oh, you're so good at this. Cool. You ready to do the real thing? Yeah. Okay, let's do this to make this competitive. You want to be the fastest, the most accurate person in the room. Please turn to your neighbor, preferably somebody you don't know so it gets weird, and go like this. And just be like, I will crush you. Come on, come on, come on. Make it weird. Make it weird. It's more fun this way. Awesome, awesome. Okay, ready? All right, hands up. Who will be fastest and most accurate? Ready, go. Oh, ready, go. Very nice. Room left is definitely smoking room right. The people in the front are a lot better than this. Person A is just crushing person B. Come on, folks. Come on. Okay, who won? Some sheepish hands and one really confident hand. I got this. Nice job. All right. Besides who won, who noticed the thing? Raise your hand. About 10 people out of 200, as far as I can tell. What did you see? So, yeah, day drinking, clear day drinking happening here. Yeah, there was a dinosaur. So maybe about 5% of you noticed a dinosaur in the scatter plot. More importantly, 95% of you did not notice a dinosaur. That's weird. This is a paper that we had at the IEEE Viz conference a couple of years ago. Tull was the first author of this. He won Best Short Paper for this. And yeah, we just got you to miss a dinosaur in the graph. Let me show you what was there. That, for graph nerds in this room, that will be a familiar dinosaur. I think Alberto Cairo designed that, and it shows up at the IEEE conference, snuck into talks all the time. If you missed it, don't worry. Look at that. That's people on the internet performing the same task. We showed the dinosaur for just a second. That's about what I tried to simulate with my clicker, and like 90% of people on the internet miss it. You show it for 2.5 seconds, and that gives you more time to change your filters and maybe notice it, and only 60% of people miss it. You might say, well, they're on the internet. Of course they're going to miss it. They're playing with their cat. No, they have to sit here and do this thing, right? They have to be watching, just like you did. They're pressing keys. They're not doing this. And we also have a control condition where we say, don't filter. Don't pay attention to just those blue X's. Just watch. And now, like, almost everybody notices it in this control condition. So the reason why this works is it's just evidence of how you don't look at a visualization and just take the whole thing in. Ooh, your visual system is so powerful, you can do everything in one shot. No, there are capacity-limited operations in your visual system that prevent you from doing everything at once. Your visual system's built to handle it. The way it does it is you take in subsets of visual information at a time. One big way you do this is with these color filters. So what I tricked you into doing is to turn up the gain on purple and X redundantly to really get some good filtering in. And then that's what your visual system is doing, is it's fading out all the green circles. And what you don't notice is that in the background, this thing was here. Anybody know of a famous experiment where there's a bunch of people playing a basketball game and a large primate walks through it? This is exactly the same thing. Dan Simons and Chris Chabris did that. Dan Simons was my PhD advisor. So I came in to the lab just like a year before that study dropped. I was like, oh, why couldn't I be one of the basketball players? I was mad. So this is my redemption, I guess. All right, so this works because these filters are really powerful because you need them. You can't process everything at once when things get complicated, and your visual system's really good at pulling subsets of visual information out at once. So you can help your audience be faster by encouraging them, by recognizing that they pull out these subsets of information at once, and encouraging them to do it in the right order. So let's fix this graph. Let's make it a little bit faster. There's a bunch of things you won't want to do in this room right now to fix this thing. First of all, instead of organizing, if you're comparing previous year to current year, why you put them so far apart? Keep your comparisons close and your enemies closer. Just remember that in your head, right? We all know this. Keep your comparisons close. Once we've done that, now we don't actually need color anymore because our comparisons are close. But you're like, wait, we kind of need color because now all the bars are just mushing together. I don't like that. Put color back, please. No, we don't need it. Just add some negative space. Ooh, add some negative space. A lot of data visualization tools make this surprisingly hard to do. Anyone ever do this in Tableau? Yeah, you know what you have to do? You have to make an invisible subtotal between all these different bars and then paint it white so it doesn't show up. Tableau, if you're listening, please fix that, right? Because this is so much better to add some negative space. All graphs don't have to be perfect Cartesian organizations. You can adapt to the visual system by adding negative space, which we need. Once we have this, there's still a problem. Tell me, those are tiny kittens if you can't see them. I'm very proud of them. Tell me are more products going up or down this year compared to last year? You still have trouble. So each one of those little comparisons, even those little comparisons, 2 bars, takes you time. They are serial. You can only do one of those at a time. Now, each one takes maybe 200 milliseconds, so maybe you can do 5 per second, but it takes time to do that. And Christy, a grad student in our lab several years ago, studied this, and she wanted to show the data visualization community that these kinds of comparisons, the cornerstone of all visualizations, the comparison, takes time. So I'll show you what she did. Her original title for this presentation, for this paper, and IEEE Viz, was "Comparisons Are Slow," but reviewer 2 said that's not precise enough, and so this is our title now. Measures of the benefit of direct encoding of data deltas for data pair relation perception. That is much better, great, yeah. We kept it. And what she did is she had people come in and we asked them questions like, are more products going up current year compared to previous year? How many are going up, et cetera? And as you guess, people stink, right? This is really hard. This is gonna take you several seconds to figure out. And then she tested a bunch of other ways of doing the same thing. So a lot of you wanna take this thing And I see the dashboard designers being like, stop, make it a table, throw your dimensions into rows and columns. And that's better, I agree, but it still is going to take you. I think you just have the amount of processing time, but it's still going to take you time. And I see the dashboard designers in the audience saying, hey, why don't you just do this and just throw some deltas explicitly on the edge? Yeah, this is a way to make it instantaneous, because now all you got to do is throw that powerful visual system onto the deltas on the right. You're basically just sort of counting the number of bars that go that way and that way. You're quick at averaging your sizes together. This is incredibly quick now. So any good dashboard designer is going to come in and say, you don't want to directly depict your deltas. The problem is that your deltas are not directly depicted, and this is what you're going to do. Folks in this room probably wouldn't use this. This is a little more industrial, cement, dashboard, brutal efficiency, right? Folks in this room are probably going to lean more towards the slope graph, and then cut down half of those lines that you don't need, and then add some annotations and add some color. And then you go, uh-oh, Nick said yesterday we're not supposed to use slope graphs, and you go back to this. And then you go, oh, it's okay. Nick said that it was bad, but only if this thing is showing percent increase. And so I'll make something up right now, and I'll say, well, no, it's the absolute value of the delta that matters, so this is actually okay. And then Nick, I can see him saying, no, there's actually another problem. Okay, I'll talk to him later. So we'll stress out about that later. Let me give you another example of how the visual system slows down, especially when you start adding semantic information. You start adding labels, you start adding a real world problem, you start adding language. I'm going to give a task for room left and a task for room right. So room left, room right, Eli's in the middle. You can choose your side, decide who you want to affiliate with. And the room left, only look at the left side, please. Go like this. Keep yourself from misbehaving. And room right, only look at the right side. And I'm going to show you, first of all, just sort of the axis for the graph. Okay, so I'll let you soak it up a moment. What I want you to do, folks, is I'm going to show the graph for like 5 seconds. I want you to pick out 2 conclusions from this graph, and I want you to memorize them. And in a moment, I'm going to ask you to tell your neighbor. Ready? 3, 2, 1, go. I'll give you a solid few seconds for this, and I'll take it away. Okay, so everybody can put your hands down. Please tell your neighbor your 2 conclusions. Go, quick, tell your neighbor. All right, 3 more seconds. Okay, stop. What have you got there? Stop there. Raise your hand if you notice something funny in these data. What the heck? What the heck? Why is only room left noticing something funny in these data, and room right isn't really, like, only a few hands went up? That was weird. They're the same data, actually. These folks over here noticed that this kid River gets shorter. That's not how growing works. Why did y'all not notice that? Well, the reason is that comparisons are slow. Semantic links to those comparisons are even slower, because now you got to bring real world knowledge and language to bear. And if you want people to notice that pattern, then you should have used the graph on the left. Why? Because we kept our comparisons close and our enemies closer. So that is why you noticed it on the left. So it's just a demo of how, if you don't set up the graph right, you can miss a dinosaur. If you don't set up your chart right, your audience can miss something as crazy as this. So I love this quote from the graph comprehension literature. It's from one of my heroes in that literature, Preeti Shah. And what they noticed when they had students trying to learn how to read graphs in the education world, they noticed that looking at a graph is not like instantaneously recognizing a picture, like that squirrel, corn, tree. It's more like the process of reading a paragraph. So her quote that I love is, reading a graph is like reading a paragraph. And I wanted to just evangelize this as a good mantra. I really love that phrase, and I just want to give her all the credit for it. Reading a graph is like reading a paragraph. And when we tested this on the internet, nobody missed that thing on the left. Everybody said, what the heck, River shrinks? And half of the people on the right missed it, because you have to slowly produce the sort of verbal representation from that graph. It takes time, and if you don't design it right, people will miss it. So this is another project with Tal, the dinosaur guy. And we used her mantra as the title of this paper. This isn't the only example we tried, just to show you it extrapolates. We tried to come up with other examples where there's semantically something doesn't make sense. So here you go, you're all noticing the weird thing that if you buy that Veritech phone, its battery lasts longer for audio-visual calls than audio calls. And not many people miss that one. And if you buy that Happy Burger, what the heck? It actually costs more than a burger and fries. That makes no sense. And notice that in these cases, you'll notice it because those comparisons are next to each other. And then on the right side of the screen, I'll put the opposite case, where we're going to put them farther from each other. And now lots of people will miss these incongruent, semantically incongruent trends. So he made up lots of little vignettes like this, where we could test this in many situations. By the way, I gave you 5 seconds because perceptual athletes, I just figured that would be a good amount of time. The regular humans who did this, like the typical humans, we gave them 15 seconds, and we still got data like this. So I figured you need about the third of the time to get it right, or you notice it, because you all do that thing that like scientists do. Be careful about which fingers I use. Where whenever you see like a 2x2 graph, you go like, okay, well this one's bigger than that one, and this one's bigger than that one. But this main effect, that thing is bigger than that thing, and these are bigger than that thing, and then the delta between these is bigger than the delta between these, and here's the real athletic. The delta between these is different than the delta. I had to learn that first year of grad school. I used to sit there and be like, like to train myself with my fingers. That was normal, totally. Okay, so you all need to do that. So Cindy Chung, former PhD student from our lab, who is now a professor at Georgia Tech, is really, I think, one of the absolute leaders in figuring out, if you give graphs, what sentences will they produce? So let me give you a graph that you'll work with. It's going to look similar to what you just saw. And what she'll do is she'll say, what kind of sentence appears in your head when you see this? How would you caption this for somebody who's hearing impaired? And participants will say stuff. There's lots of stuff you could say right now. You could say A beats B overall. You could say A beats B systematically in both East and West. You could say for A, the East-West delta is bigger than for B. You're doing this thing with your fingers right now, right? You're playing with all the possible comparisons that you can make. For the West, that's true. West beats East overall. East loses to West overall. Wait a minute. West beats East overall. East loses to West overall? Isn't that the same? Why would I list those two twice? Like, logically, those are exactly the same. But here's the thing. Psychologically, those are not the same. Psychologically, those are really different. Let me give it just an intuitive example. The word met, person A, met person B, in theory, that's logically symmetric, right? If A meets B or B meets A, it doesn't matter. Logically, that's symmetric. And what if I say I went to Outlier and I met Amanda McCulloch? You'd be like, dude, that's so cool. Well, it's a symmetric variable, right? So I should also be able to say, I went to Outlier and Amanda McCulloch met me. You'd be like, you're kind of an asshole. I'm leaving, right? Yeah. It's really different. So there's all this work from the 70s and 80s showing that language is not actually symmetric, even in these logically symmetric cases. You think about these things really differently. And you may have encountered this a little bit in your head when I said only 30% missed this. And you're like, wait, does that mean that 70% got it? And you had to do a little mental gymnastic for a second, right? I did when I looked back at my slides and I wrote the slides. So I hope you feel it there, right? We did better last quarter. Get you thinking about what you did right last quarter. We did worse this quarter, makes you think about this quarter. So it's really psychologically different. So we got a little model in the lab about how actually the way that you move your attention and your eyes around in a graph actually controls the order of the sentence that you produce. It's like language kind of follows the bouncing ball of vision in this case. And that's all work that I wish I had time to talk about from Audrey Michael and Stacy Parrott. But let me finish Cindy's study. So in Cindy's study, she asked people, what do you conclude from this visualization? And in this case, they'll say, well, West had higher overall revenue for both A and B. And then she'll give you this visualization, and they'll say company A's revenue is higher overall. And I think you've all figured out that these are exactly the same data. Right? I just did the same trick I did back for that kid getting shorter example. And then she'll try different kinds of graphs. So she'll stack them in like a little small multiple setup. And now the sentence that you get is different. And then she'll do this. And now the sentence that you get is more about the grand totals. And now you're ready to say, Oh my God, okay, cool. So if someone's doing all this work, where's the giant flow chart that tells me all this different sentences that I can, depending on the graph, I can make people say different sentences. And my answer is that's complicated. And like, I'm not gonna figure that out. Cindy's gonna figure that out. Because she is smarter than me, younger, faster, stronger, right? Like she's gonna do this, right? Like it's not gonna be me, but like there's folks working on it. And if anyone's gonna find out what that flow chart should look like, it's gonna be her. Reading a graph is like reading a paragraph. I love this presentation from last year. I just want to make a link back to it. I think it's really similar. If you saw John's presentation from last year, it's really similar to what he was explaining, that a data visualization is not some picture you put up and it's self-explanatory. It's about the words that you use to guide people through it in a certain order and the way that they semantically interpret that visualization that's in front of them. So I love this presentation. So when you have charts intended for communication, guide them through the sentences that create the paragraph that you want to appear in their head. Now, my context for visualization, the place where I study visualizations the most is PowerPoints. I look at lots of PowerPoints. I do a lot of PowerPoint training. I teach classes on good presentations and such. And this is the modal presentation slide. We have useless headline up on the top. We have a graph with no highlighting or annotation. And we have some bullets on the bottom, where I hope you see kittens watching ping pong vertically, where you're trying to figure out which one's relevant for the graph and what data support it, blah, blah, blah. So this is like a 30-second read right now. Why did somebody make this? Why did somebody make this and think, oh, you'll look at it and you'll see the story immediately? Well, you've been sitting here doing this analysis and you've become an expert in it, and that expertise has become a curse. You haven't heard this phrase before? I love it. I wish I knew about it 30 years ago. Curse of expertise, curse of knowledge, illusion of communication. There's lots of versions of it. But this person has been working on this analysis, and when they look at their own slide, their visual system goes through a certain sequence and filters in certain ways, and they think that yours does too. They think you see what they see, and you don't. So Cindy wanted to prove this in the lab. So we made participants temporary experts in a visualization, and then we got them to predict, will somebody else see what you see? Here we go, I'll make you a temporary expert. Here is a graph of election polling data from a mythical European country. Look at those deliciously, European party names, Labour and stuff. And the 4 parties, that's the polling data. Who cares about parties 3 and 4 on the bottom? They're not gonna win. The action is between 1 and 2. Let me make you an expert. So that Green Party, they were in the lead, and then there was a debate, and then the person from the Green Party accidentally insulted the intelligence of the spouse of the blue person. Not cool. You can see that made their polling numbers come together. And then time goes by, people get bored of that scandal, and then at a future debate, the blue person couldn't answer a question. And they tried to bring up that stale old scandal. That made them look weak, and you can see their polling numbers diverge again. Okay, I made you a temporary expert, right? Oh my God, wrong study. I totally forgot. Forget everything I just told you. Just wipe your memory. I'm gonna take this version of the graph. I got rid of the gray out on the bottom lines. I got rid of the annotation. And I'm gonna grab somebody out in the hall that's never seen this graph before. And I'm gonna ask them to pick out the most interesting, the most salient aspect of this graph. I'm gonna ask them to circle it. Here's a pencil. Could you please simulate what they're gonna circle? What's gonna pop for them? And you're gonna circle this, and all together, y'all are gonna circle that. You're gonna think that other person is going to think what you think is interesting is interesting. You think that they're gonna see what you see. I see reviewer 2 in the audience right now. And review 2 is like, well, come on, the top 2 lines are like, that's the top 2 parties. Of course, they're gonna see that. Maybe that prediction is right. Okay, fine. So actually we flipped a coin when you came in the lab, and we could have told you the same story about the bottom 2 lines. In this country, only the top 3 parties get into the next round and get special funding for the second round. Who cares about 1 and 2? That's boring. The action is between 3 and 4. Who's gonna make it into that second round? Same story, spousal insult, get bored, blah, blah, blah. And now if you're right, and it's really about the top 2 being more salient, they should still draw that. But if it's about an inability to ignore your expertise, then y'all should circle the bottom, and that's exactly what happens. So you think that other people are gonna look where you look. You're gonna think what is interesting to you in your visualization. You cannot shut that off. You cannot simulate someone else's brain. Sorry, that's not something that human brains do. You use your own brain to simulate other people's brains. And so the expertise that you develop on that chart has become a curse when it's time to communicate. How do you beat your curse? Well, first of all, do what most people in this room do already when you have a graph. Here's an example of a graph that's adapted from a New York Times Upshot example. You're not just going to give a vague title on the top and then some bullets where they're going to figure out how they look back and forth, and then just some data where you're not telling them where to look in the data. You're going to do the storytelling techniques. You're going to take that title, you're going to turn it into a good headline. You're going to take those bullets, you're going to turn them into annotations, and then you're going to paint what you see. You're going to actually kind of draw what it is that you see as an observer, and this is making you more guaranteed to have your audience see what you see. But then, hopefully, you're also going to test it. You're going to put it in front of people, and you're going to say, what do you see? Because you shouldn't trust your own storytelling, because you still have that curse of expertise. So do what a good designer does, and do a talk aloud, and have somebody walk you through what they see when they look at something like this. And then use gesture if you can. You're pointing to somebody else's slide, you're at a scientific poster, ask yourself, WWHD, what would Hans do? Hans has a display that looks like it was from 2005, just not meeting the declutter rules, no annotation, but you follow this insane 4-dimensional visualization that moves in time, because the guy's standing there saying, look at that thing, it's moving to the left and it means this, and look at this group and it's moving to the upper left and that means that, and he's grabbing your eyeballs and telling you what to filter for, and then telling you linguistically what it is that you just saw and how to interpret it. That is the other major way to do storytelling. You can't put it on the slide. So that's why this video is so inspirational to me. So this is a PowerPoint. Let's just quickly do the same thing. Something more like that. Plenty of opinions in the room already about how to improve this, but you get the idea. This works, by the way. We ran a study on this. You may recognize that fourth name in the author list there. You may recognize Elsie Lee sitting up there in the back. And that's Cindy as well in the author list. And we wanted to test the usual guideline that happens in the data storytelling literature. 2 steps. Take your cluttered graph, declutter it. Once it's decluttered, storytelling. Lots of claims about all those 2 steps. Do they actually help? The decluttering step in particular was claimed to make your graphs look more professional, but also be cognitively more understandable, more memorable, etc. Long story short, we found that that step doesn't actually really help the cognitive part much. It makes you look cooler, makes you look more professional, right? But it doesn't actually help the cognitive part that in a way that we could find. But that second step, declutter, to adding the focus, give a good headline, paint what you see, led to 3 to 4x more understanding and memory for your important story in the data. And we asked people questions. We had people redraw the graph from memory, and the graph was coded to see what they actually remembered and what they said. So we tried every way we could to pull that signal out of these data. With great power comes great responsibility. Please, if your data visualization, if there's many possible comparisons that people could make, then you want to make sure that you are giving the right comparison, the ethical comparison. I'll give a link back to Eli's presentation from yesterday, where if I have this graph, and this is adapted from the New York Times Upshot, I'm basically just retelling their story in this great interactive that they have, and you could show this from the Republican or Democrat perspective, the blue party or the red party perspective, then this is a blue president that they're talking about. You could say, check out this orientation drop. Look at that, this president takes over, unemployment goes down, go Obama. Or you could take this same data and you could draw a line and say, this president promised 8% unemployment. And look at that area over that line under the curve. Every pixel in that red area is 5,000 people without a job. They can't put food on the table for their family. Obama. Right? It's exactly the same data. I don't have any opinion about which one is right? The point is that based on the way that you guide people visually through these same data, you are creating different sentences in people's heads, which lead to these vastly different conclusions. Great power, great responsibility. And if you think that people will just see the other pattern, remember the dinosaur. Remember the dinosaur, right? No, they won't necessarily see it. You can miss really obvious stuff. Remember that kid that you didn't notice got shorter. You can miss really important stuff. All right, there's a QR code up there. This webpage has everything. This webpage has a 30,000 word paper that will review the psychology of data communication for you with this all-star cast up there. Some names you'll recognize, Lace Padilla, Preeti Shah I talked about, Jessica Holman. So that one's up there and linked. There's the dinosaur paper and a link to trick your friends with the dinosaur if you want. This page has everything. Matt Kay's home phone number. It's up there. It's a landline. It's a rotary phone. He likes that. It's got a link. If you want Steve to come and train your company on PowerPoint, you call me. There's a new app there that's supposed to replace PowerPoint. The link is in there. Recipe for shrimp chips. It's got everything. Anything you all would want. It's all on there. And it also has a little invite to a big dinner tonight. There's no dinner tonight at the conference, so I'm just declaring Timeout Market, 6:30. Lots of info in there. Just come by. Let's just go party at Timeout Market. Yeah, cool. Here's the summary. Usually we talk about vision being fast and language being slow. It's not that simple. Visuals really slow down when you get to comparisons, and they really slow down when you get to comparisons linked to language and labels. And so what you want to do is to guide that mental sentence, guide that mental paragraph, and you say, yeah, I'm doing that. No, you might not be. We all have that curse of expertise where if we don't guide them, oh boy, we're in trouble. If we do guide them, it still may not be working because it's working for you. Go out and test it. Put it in front of somebody and say, look at this thing. Talk. Go. Right? Every designer in this room learned this in like second day of Design 101, where you do talk alouds for products that you make or websites that you make, whatever. Do the same thing for your visualizations. I've actually been surprised at how little this happens, even in the professional world. Or it often happens with your colleagues who have a certain way of knowing your style. It doesn't happen with sample users of that thing that you've made. I do the same thing. And just use those storytelling techniques, guide that paragraph with headlines, annotations, highlighting, design hierarchy, verify it with a talk aloud, and you're done. Thanks, y'all. Your call.
All right. I can't. Hello.
Let's try all the mics until one works. This one works. Here.
There we go. Yeah.
You should hold 3.
No, I don't want 3. That's too many mics. Thank you for a great talk. I think lots of interesting insights and callbacks to some of the presentations from yesterday. I love your call out of your own slope graph. I'm curious to see if Nick is in a line somewhere.
Nick's quietly fuming in his chair.
Quietly fuming. Excellent. But excited to dive into the questions from the audience since I see we've got a line. And do I have someone monitoring our virtual questions today? Excellent. All right. Let's go ahead and start over here on this side and tee you up first question of the day.
Awesome. Thanks. Thank you so much for this. This is very cool to see the different types of processing. But harkening back to yesterday and accessibility, how do we account for neurospicy folks? How do we account for differences in visual processing, language processing, auditory, if that matters? You said a whole lot about how we do things. Who is we? And how do we account for the not we?
Do I need to repeat the question a little bit? Yeah, so it's fine. I'm happy to. So I use the word we a lot, and I'm just assuming that we is one thing, and I should not be doing that. There are folks that have different accessibility challenges. I love this new term, neurospicy. This makes me very happy. And so 2 things to say. Number 1, yes, I didn't cover accessibility today. You've got a visualization. You better have your alt text. You better make sure your color palette is the right kind of color palette. You better make sure your font size is hitting the minimums. You better make sure your contrast is high enough. All the wonderful guides that are out there, Outlier projects, etc. I will mention that beyond that, there is a lot of consistency more consistency than is often recognized in other human brains. Like you often hear about how people have different learning styles, and some people like to learn verbally or visually or kinesthetically. Accessibility aside, and extreme cases aside, the education literature for the last 30 years shows that that's not true. So learning styles, I'm happy to send a review. I'll add this to the webpage later on today, a review paper on how learning styles, actually there's no evidence that they exist. So worry about folks that that are in the usual accessibility umbrella, neurospicy folks, but don't worry about the learning styles literature to the extent that anyone's researched it. There's little evidence that it's important. So I'll give you two sides of the same coin. Thanks for the question.
Off to the left.
Yep, we have a virtual question from Hana Khan. It's a two-part. So the first question is, have you done any studies on visual thinking with maps for exploring and wayfinding? Especially curious about wayfinding since we are often multitasking at that time, moving ourselves on our mode of transportation while navigating. And I'll go to the second part. Regarding reading a graph being like reading a paragraph, do you think that people will have an easier time processing maps that are in satellite mode versus in the default mode? Because people may process the satellite mode more like a picture versus a graph.
I love these questions. Super cool. To repeat them, the question, to summarize, what's up with maps? And how do people who's studying navigation and why some people are good at it and bad at it? And then what's up with the more satellite view mode versus the here's which way I'm going mode, right? When you tap in your phone, you can decide, do you want my little blue dot to go like up and down, north, south, or do you want the map to spin to go in the same direction that I'm going in? I don't do this research, but there's a huge community called spatial cognition. If you look up Spatial Cognition Conference 2023, I think they had it last time, there's a ton of people that work on this. One of the epicenters is actually UPenn. If you look up names like Nora Newcomb or Russ Epstein, you're going to find really cool studies of exactly what you're talking about. Long story short, it's a huge problem. It's a really tough problem. People study it with paper maps. People study it with VR. Paper maps, you get kids that are in 4th grade and you just ask them to use a map, and you can imagine it's hard, right? How do you teach them how to do that? There's a bunch of little tricks you have to teach them where if your blue dot is going down on the map, now left becomes right and right becomes left. There's these little heuristics you can teach people, because this is one of the places where there are differences. The one place in learning styles, to go back to our last question, where there are some differences is that ability to like read a map and navigate. You all know somebody who can drop in a brand new city and they're like, I got this. And then somebody else who can't find their way home. And there are people that literally, like, in order to go left and right in a car, they have to remember, like, I turned the wheel this way. Oh, I'm going to the right. Like, I've known people that do that. So this is a place where there is a lot of human variation. For the egocentric versus map-centric perspective, there is a lot of work in these literatures right now worrying that because your phone turns the map, you're not actually learning the map. And so there's work with a lot of college undergraduates who have like grown up and have never actually held a paper map and they just use their phone to find out whether they still can read a paper map because they've gotten used to that hand holding and haven't developed that ability to think like, well, I'm going down on the map and now I have to reverse left and right relative to this little blue dot. I don't remember the answer to what happens though. So sorry to give a big build up and not know the answer, but those are the people, Nora Newcomb, Russ Epstein. There's a whole spatial cognition center there. Check out, just Google them and check out their webpage. And they are like the forefront of a lot of that work. Yeah.
Letitia?
Hello. Thank you so much for the work that you put out. It's one of the works that I have used the most this year, so I'm really happy to be here. One of the things that usually people say when they're building dashboards is that people get accustomed to or they get used to the charts that are there, and they need some time to get into it. I wanted to get your perspective based on everything that you said. What are the good things and the bad things that can come from that? And if you believe that that is actually a learning, there is a learning curve that people get accustomed to, and you know, what is it that we should think about when we're doing that? Because I know it's an iterative process, but at the same time, it's like we need to put something out, a product out.
Yeah.
So I wanted to hear your perspective on that.
So the question is essentially, how do we recognize that people don't know how to read particular charts and teach them quickly, if that's a fair summarization?
Yeah, but at the same time, like, do you believe that people do that? Is that something that actually happens, or is it just another limitation for people to actually use dashboards? It's because they don't understand it. Cool.
Plus cursive expertise. Do people recognize that their audiences don't know how to use their fancy new chart? So just to couch this at the beginning, like you all had to learn how to read a bar chart. When you were in second grade, your teacher asked you, what sport do you like? And you like football, you like basketball, you like tennis, and they like stacked up a bunch of each of those sports balls. And the higher the stack got, more people like that sport. And then they said, notice that the higher the stack is, that's more people. And then they gradually faded out the actual sports balls and they replaced it with a rectangle. Because learning how to read a bar graph is something that you have to learn that. Is it the width or the height of the bar that matters? Is it the top or the bottom that matters? And the teacher explains that, and then go to the top of the bar and then read off the number. And there you go, you got the number. And you're like, why didn't you just give me the number? And then they explain, then they go, oh, visuals are very powerful, right? There's a reason why you want to translate to this other domain. And I was chatting with Nick the other day, and he said, as he's talking with organizations, he's shocked at how many people don't know how to read a scatter plot. I would guess it's the vast majority of people in the world. I would guess it's the majority of college graduates don't know how to read a scatter plot. Yet we just show these things because we have that cursive expertise. So there's a great literature in the visualization world on visualization explainers. How do you take a stepwise approach to showing the independent, here's how you read the axis, and here's what this one means, and let me add this encoding. There were some great suggestions yesterday on how to do this. Let me give just one extra suggestion that hasn't been mentioned. It's typically in the PowerPoint domain where somebody has a new chart and they know that their boss won't be able to read it, but they think it's better. And this is stolen from the education literature, where you put up the old thing that people are used to and you gradually introduce the new thing. They learn how to read it, they learn to trust it. This comes from when you were learning algebra in 8th grade and you had the formula, y equals mx plus b, and then the graph. And then eventually you don't need the graph anymore because you learned how to read the formula, but they keep them up simultaneously for a while. So that's my advice to y'all is to put up the old thing, let people read it, let them trust it, and then they get the new thing, and I can see all the same patterns, I'm learning, and then by the 5th time you put them up, don't put the original up and see how it works. That's one extra trick for getting people to at least trust the new visualizations.
Do you have any other question from online?
We have another virtual question from Miriam Berkowitz. If your graphs are not static and continually update with new data over time, the paired graph may be different over time. How frequently do you revise the headline?
Love this. More often than, the question is if you've got dynamic graphs, then let's take the Rosling one, right? Where he wants to point out hey, these countries are here, now these countries are here, and you need to call out patterns over time. How often do you revise the headline? I would think don't revise the headline, but and this is an opinion, I don't have research on this directly, but revise the annotation and call it out over time. The problem with animated graphs is that the old patterns disappear. Right? That's the big issue with them. They're engaging, they're dynamic, but in the lab, we have a big National Science Foundation grant, and a grad student, Ayoshun, whose whole job in grad school is just to figure out why dynamic graphs are engaging and cool, but 80% of the time they're super confusing. Why? Because you're adding this dimension of time, and if you don't get it the first time, sorry, you're in trouble, and now you gotta press rewind. Oh, it's a presentation, you can't rewind? Sorry. So that's the trouble with it. So I would keep revising the annotations. And I'll put this up on the same webpage. Oshun has a guide that she's developed over the last few years of what are the limits in the visual system that dynamic visualizations tax, and what are the ways that designers have figured out to help people overcome those limitations. And they're going to be things like interactivity, so you can scrub back and forth. They're going to be things like make sure you show the annotations. They're going to be things like do what Hans does with gesture, but do it with highlighting. Things that collectively folks in this room already use, but compile it into a single guide. So I'll make sure that goes up on the website.
Ping?
Hi, yeah, so my question is similar to contesting the definition of the we that you're describing in a lot of this research that you do in terms of percentages of who responds to these charts. And I'm just wondering if your research covers cultural differences for societies that read right to left instead of left to right, and they would think of a paragraph a little differently, but also different visual cultures. For example, in Japan, I don't know if people here have been to Japan, but you would see very often the live infographics that are just completely overwhelming. Every single fact and information is on that visual, and that is their preference. It's not, simpler the better. So I'm just wondering if you've accounted for those differences.
I love this question. I would really invite dialogue and examples on this question because To my knowledge, just to repeat the question, what if you're from Japan and text typically goes up and down, or what if you read Arabic or Hebrew and text goes left to right? And there are cases where, let's take the Hebrew case, where like the number line in the classroom, and in where you have folks that just speak that language, the number line goes the other way. It's from right to left. And so should you design, and some graphs, if you go to an environment where people just speak that language, will actually be designed differently. So that answer is yes. Typically, the folks that I tend to encounter have seen multiple perspectives and can sort of adapt. They know what the intent is. Should they be doing that? Should we be just accommodating what those other folks are used to? Sure, but that's just a big conversation that's complicated. But I absolutely agree. The other place where that happens sometimes is color. So you go to the Beijing stock market and like, it's not red is bad, but now red is great. It's like weddings and celebrations. But then those folks might leave that country and they'll know that in other places, red means something different. I don't know, should we accommodate to that? Should we try to flip it when we're speaking to those audiences? That again is a complex conversation, but just acknowledging, yes, those are the two places that I know of where cultural conventions are a localized sort of expertise that will guide those sentences and the interpretations. Those are the two that I'm familiar with. If y'all have more, I'm very curious to chat about it.
This sounds like a very good unconference conversation.
Yeah.
Zane?
Spectacular talk. We just read Invisible Women for the DBS Readers Club, and a question that we had in our discussion was, are there differences in how men and women perceive data visualization? So my question is, have you looked at sex disaggregated data, and are there differences in how people of different sexes perceive and process data viz?
No, I have not done this work. The person that you want to read that has done this work is the person that I mentioned already, Nora Newcomb, one of my absolute heroes, Temple University in Philly. She does a ton of work on, it's more on like spatial cognition and navigation and math scores and SAT scores and men and women, where the differences come from. And what she will argue is that you will often find, I don't think anyone's done it for graphs. Which I'll say what she argues, and I'm going to graphs. What she will argue is that there can be differences between biological sexes in tasks like this, but they typically are in the extreme of tails. And she thinks it could be chalked up to when you meet a little baby girl, there's a little pink bow on their head, and you don't give them a truck, and you meet a baby boy, and you give them a truck right away, like those kinds of nurture versus nature issues. So that is her argument. For graphs, I don't know that anybody's done the work that needs to be done. I think you can find plenty of papers at IEEE Viz, at CHI, in the education literature that will say, oh, and we had our 30 people and we split them up into men and women to see whether there was a difference. And it's like, okay, great, 15 versus 15, and maybe they find something, maybe they don't. Are you sampling in the same way? Like, oof, that's a really hard thing to sample. It's a complicated problem. So I would put a giant lump of salt on any of those results and trust whatever Nora Newcomb says. But I don't think there's going to be anything on graphs in particular.
Thank you.
Yes.
My name's Ben. Thanks so much for your talk. I'm wondering about the Hans Rosling example of the explainer. Do you think storytelling would be a good format for sort of overcoming the challenge of the video that you just mentioned, or making sure that the user does have the ability to rewind to your point earlier?
Yeah, I love it. So the question is, if you had something like the Rosling graph and it's animated, and so you lose the memory of what happened before, would scrolly telling be a good mechanism for giving people that interactivity? Yes, absolutely. Well, one of the ways of fixing it is interactivity. You can rewind, you can watch it again, and when you watch it again, you now know what the thing is that you were supposed to pay attention to. So you pay attention to it. And yeah, scrolly telling, steppers, scrubbers, where you can just move a movie, like in YouTube, any of those are going to be mechanisms that you can use to go back with that right filter over your eyes and see what you were supposed to see. Absolutely.
Is there any research that you're doing on that, or any folks you can recommend?
The relevant research would be if you pop in into a search engine, IEEE Viz, interactivity, dynamic animation, something like that. There's going to be 7 papers in the last several years that look at the benefits of interactivity for the people understanding animated displays. Absolutely.
Eli?
Hi, Steve. You mentioned a couple of things, like scatter plots not being familiar in certain, I think it was from Nick, and the age-old problem of how do I get my boss to understand this chart. Are there benefits to familiarity for, like, how do you think about the trade-off between like familiarity versus maybe a more visual system optimal version of a chart? Like, how would you kind of make those trade-offs or think about those trade-offs?
Love it. When I first started doing PowerPoint trainings for companies, I would see like what they call a P&L table, profit and loss, and it's just like a bunch of numbers. It's a spreadsheet. It's all text. It's like, I'm going to make this into a graph, and I turn it into a heat map, and I put bars in there, and I tried to make a scatter plot, and lots of I didn't know what I was doing. And then the people looked at it and they're like, this is the stupidest thing I've ever seen. And why are you doing this? And one of the reasons was I didn't understand the business problem and I didn't understand what they wanted. But the other reason was they had stared at that texty table for so many years that actually, if you've done this, like little numbers, they become baby bar graphs because the numbers get longer as the order of magnitude increases. And they can look at that table and their eyes go pop, 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 pop into exactly the right locations. And if you take that expertise away, they're in big, big trouble. They spent 15 years developing that eye movement pattern and integrating with their thinking. The metaphor I like to use is, I'm like, oh, I'm obsessed with airplanes. I watch videos on like airplanes and like, what if I were to be a pilot and like the cockpit controls and like, what does this knob do? I get very excited. And whenever I walk into an airplane, I look at the flight deck and I'm like, oh my God, that's the most complicated thing I've ever seen. How does this plane ever take off? And I think, what if I redesign that? Well, what if these things go over here? And what if I objectively redesigned it to be better? That plane is not taking off. Because those people are light, right? They've spent literally 3,000 hours staring at that display. And so yes, there's always a trade-off. You lose the expertise when you go to a new format. Is the new format a big enough win to go through the training and give them that extra power? That's your call as the designer. That's a conversation. Yeah.
Let's go ahead and take our one last question. You've been very patient as a quick one, and then we'll wrap up with our keynote for the morning.
Thank you. Oh, question. Thank you for the talk. Appreciate it. Your title kind of harkens to Kahneman's work, Fast and Slow, and I think that the theme in data viz is fast is better. I want to ask you, when is slow better? Because as we know from kind of other cognitive work, there is a trade-off. There is a reason why slow exists.
Awesome question. The fast and slow, I think, maps really nicely. So the question is, how say more about the fast and slow, and fast ever better, slow ever better. The fast really and slow really maps because in the Kahneman sense, what you do is the fast thinking is thinking that's reflexive and thinking that's often, and it can be very powerful, but it can also be incredibly biased. And the slow thinking is more algorithmic, it's more careful, but it's tougher and it takes time. And I think the equivalent of that in vision is when you look at an image of the real world, there's a lot of fast reflexive things you can do. You're in an auditorium, there's 200 people. But then if you want to make tougher decisions, if you want to make real-time decisions that are arbitrary and that interact with the rest of your brain, like, does that person look happier or angrier than that person, or have I met that person before? It gets very serial. So I think the mapping actually works. There are research papers where people try to get students in particular to slow down on a visualization. There's a literature called desirable difficulties. This is like in education when you're taking, instead of a multiple choice test, fast, recognize, do it. Oh, now you're gonna write an essay. Students hate that because it's slow thinking, but you'll learn a lot more. And there's a literature on getting people to read a visualization more slowly and to adapt those same kinds of tricks to get people to enjoy the meal and take their time and therefore get better memory, better understanding, put things in their own words, etc. So the literature to look up is called desirable difficulties.
Thank you.
Yeah.
I feel like I know more about library science and where to search for things now, having listened to this Q&A. Huge thanks to you, Steve, for that great talk. Big round of applause for Steve. And as a reminder, especially for folks online and folks in the room, if you have additional questions, feel free to add them onto the questions channel for our speakers. I know our speakers have been trying to follow up and answer questions there. And I'll just send the one last shout out of, if you don't have evening plans tonight, Steve has given you a dinner invite for the evening to head over to where again?
Timeout Market, 6:30. Virtual folks, you're in Indiana. Get driving. Let's see you there.
So Timeout Market at 6:30 if you'd like to go ahead and join and meet some other DVS folks and DataViz folks outside of the confines of our lovely auditorium.
Second floor.
Second floor. Don't go there. With that, I'm going to go ahead and hand the mic over to Emily. We'll go ahead and move along to our lightning talks, but it'll round out the first block this morning. Thanks again, Steve, for the great presentation.
Thanks, all.